Hi class, this is chapter 14, lesson 5, and this should be a pretty short lesson because when we were doing lesson 4, I went ahead and referred to perimeter and area, and this one is area, so there's nothing exceptionally new here. We've already talked about how Archimedes used polygons to help him come up with a reasonably precise number for pi, so that he could find the perimeter of a circle or its circumference. Okay, so we're just continuing with that with area. And so we're using the same idea of a hexagon that's inscribed in a polygon. And then you see this dark blue around here. That is where we see our dodecagon, our 12-sided polygon, inscribed in the same circle. Which gets very close to approximating the area of the circle because it covers almost all of the circle at that point. Continuing on, again, like we said previously, with a 6-sided, 12-sided, 24, and then 48-sided polygon, we get very, very close to a circle. And as that number of sides increases, we get closer and closer and closer to it. And we approach the actual size of the circle. And so we say that there's a limit to how close we're going to get, because it's not going to get infinitely bigger. It's going to be limited by the bounds of the circle itself. Okay, and we can see this chart here again showing if you take that area formula for the area of a polygon, where that m was, remember, representing that sine and cosine of 180 divided by n, all of those pieces. If that is m times r squared to give the area of the polygon, this is showing as n, the number of sides, increases. Here's where that formula goes. So with 6 sides, m is about 2.59. At 12 sides, it's 3. And it keeps going up and up. By the time we get up to over 3,000 sides, we're at 3.1415904, which is very, very close to pi. Okay. We then see we have a little problem here about the German city of Cologne. It was originally a colony of the Roman Empire, and it's located on a river. So we have a nice clean picture here, but look, you can see here kind of an overview of the city. So here's the river, okay, the Rhine River, okay, Colonia Agrippina, okay, and the river forms one side. We make it a nice straight side over here. So one boundary of the city is already set, and so they built a wall around this city, okay? And you can see that they did kind of the shape of a rough semicircle, okay? So why was it built with a semicircular shape? Well, it turns out that if you have a certain boundary already set on one side, like a river, some straight line over here that you can't change, that walls of a given length built against a boundary such as this river, a circular wall is going to enclose the greatest area. Okay, and he shows kind of some examples here that if you were going to use the same amount of material and build the same length of wall, okay, so pi r, 2 pi r would be if you had a wall going around the whole thing, right? 2 pi r would give the circumference. So we're just half of that because it's a semicircle. So just pi r would give the length of that wall. Okay, here it shows if we tried to do a rectangular wall instead. So we want the 3 sides